morning student. Today we will solve examples based on osmotic pressure and one top factor. Example 1. Calculate the osmotic pressure. Calculate the osmotic pressure in a Pascal exerted by a solution prepared by dissolving 1.0 gram of polymer of a molar mass 185,000 gram per mole in a 450 ml of water at 37 degrees Celsius. In text, example 2.12. So how to solve this example? We have to calculate the osmotic pressure. That means we have to calculate the pi. Pi equal to pressure and we have to calculate in Pascal unit. Prepared by dissolving 1 gram of polymer, that means the mass of a solute is given. Mass of solute, that means W2 is given, that is 1 gram. Having a molar mass is given, that means N2 185,000 gram per mole in a 450 ml. That means the volume is given 450 ml. But when we are calculating osmotic pressure, always the volume is used in liter. That is 0.450 liter of water at 37 degrees Celsius. That means temperature is given 37 degrees Celsius, but we have to use always in Kelvin. That means plus 273. That means 310 Kelvin temperature. Now use the formula of osmotic pressure. So we know very well formula for osmotic pressure is pi equal to W2 RT divided by M2 into V. That means W2 is given 1 gram. Now we have to calculate in Pascal. So first we will calculate in bar unit. The value of R equal to 0.08314 liter bar per mole Kelvin. Then finally we will convert it to Pascal. That means R equal to 0.08314. Now temperature is 310 Kelvin divided by M2. Molar mass is given 185,000 into volume, always using liter. It is given 0.450 liter. Now simplify. When we are simplifying, then we will get answer 3.096 into 10 power minus 4 bar. So answer comes in bar unit because value of R is in liter bar per mole Kelvin. We have to calculate in a Pascal unit. So we know 1 bar equal to approximate 10 power 5 Pascal. Exactly 1.0132 into 10 power 5, but we can use approximate 10 power 5 Pascal. That means 3.096 into 10 power minus 4 multiplied by 10 power 5, because 1 bar equal to 10 power 5 Pascal. So this will be answer in Pascal. Simplify, then answer will be 30.96 Pascal. That means osmotic pressure pressure is 30.96 Pascal. Now second example, determine the osmotic pressure of a solution prepared by dissolving 25 milligram of K2SO4 in 2 liter of water at 25 degrees Celsius. Again, information is given assuming that it is completely dissociated. So we know here solute is K2SO4. K2SO4 is ionic compound. That means it is completely dissociated. It is given. So how to solve this example? Now we have to calculate the osmotic pressure. That means we have to calculate the pi. By dissolving 25 milligram, that means mass of solute is given W to 25 milligram. Always use mass in gram. That means 25 into 10 power minus 3 gram. K2SO4 is given in 2 liter of water. That means volume is given. That means 2 liter. Now compound is K2SO4 is given. So K2SO4, that means molar mass. Using atomic mass of potassium, sulfur and oxygen, it becomes 174 gram per mole. Now temperature is given 25 degrees Celsius. So convert into Kelvin. Always use temperature in Kelvin. So 25 plus 273, that means 298 Kelvin temperature. Now K2SO4 is given. It is completely dissociated. Completely dissociated. K2SO4 is ionic compound when it is completely dissociated. That means when K2SO4 dissolve in water, then 2K plus SO4 minus 2. That means it will produce 2K plus ion and 1 SO4 minus 2 ion. That means here from 1 moles of K2SO4 it produce 2 particles of K plus 1 and 1 particles of SO4 minus 2. Completely dissociation is given. That means this is 2 particles and this is 1, so total particles are 3. That means when K2SO4 is dissolved in water, 3 particles are produced. That means the value of I equal to 3. One-top factor equal to 3. When completely dissociation is given, then the value of one-top factor I equal to the numbers of particles, otherwise numbers of ion which are produced when compound is dissolved in water. Now use proper formula of pi. So we know to calculate the osmotic pressure, pi equal to W2 RT divided by M2 into V. But K2SO4 is electrolyte. That means one-top factor we have to use to multiply by one-top factor I. Now pi equal to value of I equal to 3. W2 mass is given 25 into 10 power minus 3. Now value of R you can calculate in any unit. That means suppose R is taken 0.082 liter ATM mole Kelvin. Then osmotic pressure will be calculated in ATM unit. Suppose we are using 0.08314 liter bar per mole Kelvin, then answer will be in bar unit. Now we are using 0.082 liter ATM per mole Kelvin. The answer will be coming ATM unit. Temperature is 298 divided by molar mass M2 is given 174. Again volume is compulsory in liter. Here 2 liter is given. All values are in proper unit. That means when this can be simplified, answer will be like this: 5.27 into 10 power minus 3 atm. That means answer of osmotic pressure is this: 5.27 into 10 power minus 3 atm unit. Next example is based on one-top factor and dissociation and association. 2 gram of benzoic acid, 2 gram of benzoic acid C6H5OCH dissolved in 25 gram of benzene. So depression in freezing point equal to 1.62 Kelvin. Kf of benzene is given 4.9 Kelvin kilogram mole inverse. What is the percentage association if it forms a dimer in a solution? Example 2.5. Now how to solve this example? The 2 gram benzoic acid is dissolving 25 gram of benzene. That means the mass of solute is W2 equal to 2 gram. Now benzoic acid is given having formula C6H5OCH. That means we can calculate molar mass. The molar mass of benzoic acid 122 gram per mole. Dissolving 25 gram of benzene, that means the mass of solvent 25 gram. So depression in freezing point equal to 1.62 Kelvin. That means the value of delta Tf is given. Depression in freezing point, that is 1.62 Kelvin. Now Kf is given. Kf for benzene is given 4.9 Kelvin kilogram mole inverse. Now all information is given. We have to calculate the percentage association. Again, if it forms dimer, that means value of n equal to 2. For dimer, suppose trimer is formed, then 3. So first target is to calculate the I, one-top factor. So use this formula, delta Tf, we know very well, delta Tf equal to Kf into W2 1000 divided by M2 into W1. Now we have to calculate the one-top factor, that means here multiply by I, one-top factor. Now delta Tf is given 1.622. Now we have to calculate I. Kf is given 4.9. W2 is given 2 gram 1000 divided by M2 molar mass is 122. Again W1 is given 25 gram. That means 25. Now simplify this and you will get answer of I1 method. When this is simplified, then value of I will be 0.5042. This will be the value of I. Now once the value of I is calculated, then it is easy to calculate percentage association. So for that, first calculate the degree of association. So we know degree of association. Degree of association. Degree of association, suppose symbol is x. Otherwise, we can also write alpha. Now x. So we know formula of x, that is 1 minus I n upon n minus 1. Now 1 minus I equal to 0.5042. N means how many molecules are associated. So here dimer, that means value of n equal to 2 upon 2 minus 1. Now when simplification is carried out, 0.9916. That means degree of association. Suppose a percentage of association, then multiply by 100. That means 99.16. Approximately we can write 99.2%. That means degree of association is 99.2%. Now next example, calculate the depression in freezing point of water when 10 gram of CH3, CH2, CHC, LC that means 2-chlorobutanoic acid is given, is added in 250 gram of water. 250 gram water. Now 2-chlorobutanoic acid is a weak acid. For that ionization constant is given, because when it is dissolved in water, ionization takes place. The value of ionization, otherwise dissociation constant is given, that is 1.4 into 10 power minus 3. Again value of Kf is given 1.86 Kelvin kilogram mole inverse. Exercise example 2.32. How to solve this example? The first target is calculate the molarity. That means all information is given. So 10 gram, that means mass of solid. W2 is given 10 gram. 10 gram of 2-chlorobutanoic acid is given. From that we can calculate molar mass. So molar mass M2 equal to 122.5 gram per mole. Is added in 250 gram of water. That means the mass of solvent is 250 gram. Now Ka is given, Ka. So 1.4 into 10 power minus 3. Again Kf is given. So Kf equal to 1.86. Now first target is calculate the molarity. That means we know molarity equal to W2 into 1000 divided by M2 into W1. This will be step 1. Calculation of molarity. Now W2 is 10 gram 1000. Now M2 is 122.5 and W1 is given 250 gram of water is given. Now when calculation is carried out, then answer will be 0.3264. That means molarity is calculated. Step number 1. Now next step, dissociation constant is given. That means CH3, CH2, CHCl, C double Y. When dissolved in water, then it will be produced CH3, CH2, CHCl, C double O minus plus H3O plus ion. For such type of equation, we know the relation Ka is given by C alpha square 1 minus alpha. Dissociation constant of weak acid. Now approximate we can write the C alpha square, neglecting the value of alpha for an easy calculation purpose. So now we have alpha equal to K equal to C alpha square. That means alpha equal to under root Ka by C. Now value of K is known. That means value of Ka 1.4 into 10 power minus 3 divided by C concentration. Here we can use molarity for dilute solution 0.3264. Now simplify this. When this is simplified and the square root is taken, then answer is 0.065. Alpha is there. That means degree of dissociation is 0.065. Now from that we have to calculate the I, quantum factor. That means this will be the step number 1. Calculation of molarity. This will be the step number 2. Calculation of alpha. Now this will be the step number 3. Step number 3 is calculation of I, quantum factor. So we know alpha equal to I minus 1 upon n minus 1. Now alpha is 0.065 I minus 1 n. N is the numbers of ion which are produced when completely dissociation occurs. So here from 2 chlorobutanoic acid 1 and 2, 2 ions are produced. This will be 2 ions. That means value of n equal to remember 2 ions are produced. Suppose 3 ions are produced and value of n equal to 3. So here value of n equal to 2. When this is simplified, then value of I equal to 1.065. Value of I is obtained. Now finally last step. Our target is to calculate the depression in freezing point. That means delta Tf equal to Tf into n. But here dissociation occurs, so we have to use formula by multiplying I. So delta Tf equal to I Tf into n. That means I equal to 1.065. Value of Kf. Kf is 1.86 into molarity is calculated 0.3264. 0.3264. Now when this can be simplified, answer will be 0.65 Kelvin. That means delta Tf. The depression in freezing point is 0.65 Kelvin. By this method in 4 steps, It can be calculated first step, calculation of molarity, second step, degree of dissociation, third step, calculation of I, and finally using this formula of one term factor can calculate delta